Did you know that 90% of turbo diesel owners are killing their engine right now? And every one of them thinks they are being responsible. If you drove yours this morning, you almost certainly did something that will cost you thousands of dollars. The dealer never mentioned it, and the manual does not explain it. The habits that feel completely responsible, the ones you picked up from forums, YouTube, and well-meaning advice, are quietly destroying your engine as we speak. Most turbo diesel owners will not find out until the repair bill arrives. A turbo replacement runs $1,500 to $4,000. A full engine rebuild is $8,000 to $20,000, and in most of those cases, the engine did not fail. The owner failed it, slowly, with habits that felt completely normal. This is the countdown of the 17 worst things you can do to a turbo diesel, ranked from least destructive up to the single most common killer. The entry at number 1 causes more turbo diesel failures than everything else on this list combined. If you drive a turbo diesel in the city, you are almost certainly doing it every single day without knowing it. By the end of this, you will know more about keeping a turbo diesel alive than most workshop technicians will ever tell you. And at least one of these is going to make you think about something you did this morning. Number 17 is running low cetane or contaminated fuel. A diesel ignites by compression, not a spark, so fuel quality is everything. Low cetane fuel ignites late. This causes hard starts, engine rattle, and unburned fuel that washes cylinder walls and thins the oil. That oil thinning is not just a side effect. It has its own entry later in this list, and it is one most owners never think to check. Water in the fuel is even worse. It corrodes the injectors and high-pressure pump. This destroys the fine tolerances that modern common rail systems rely on. Buy from busy stations with fresh fuel, drain your water separator when the light comes on, and use a quality additive in cold weather to raise cetane and prevent gelling. Bad fuel is one thing, but what people do when a cold engine refuses to start is even worse. Number 16 is spraying ether or starting fluid into the intake. People do this when a turbo diesel is hard to start in the cold, but ether ignites violently under compression well before the piston reaches the top. That premature explosion hammers the pistons, bends rods, and cracks ring lands. If your turbo diesel is hard to start cold, the fix is functioning glow plugs or a block heater, never a can of ether. Number 15 is ignoring boost leaks and a cracked intercooler. The turbo pumps compressed air through the intercooler into the engine. Any leak in that path causes lost boost and black smoke. This forces the turbo to spin harder to compensate. On a Ford 7.3 Power Stroke, the intercooler boots are a known weak point, and replacing them with upgraded units can restore boost from 5 psi back to 25. On the newer 6.7 Power Stroke, the weak spot is the plastic cold side charge air pipe, and the fix is an aftermarket aluminum pipe. On the 6.7 Cummins, the most dangerous boost leak source is a loose grid heater bolt, because if that bolt fully dislodges, it drops into the cylinder and grenades the engine. And on the Duramax LB7, the hot side intercooler pipe rubs against the power steering lines until friction wears a hole through the pipe. The deceptive part is that the pipe rests against the hose that is wearing through it. It seals the hole at low boost and opens under high boost, so power vanishes without warning. Either way, a cracked pipe or a split boot throws a code like P0299 for underboost. Check every clamp and boot, listen for a hiss under acceleration, and fix leaks before the turbo overworks itself to death. And a turbo that constantly overworks runs hotter than designed. Keep that heat in mind when we get to number 3. Those leaks rob the engine of air. The next entry robs it of control entirely. Number 14 is adding performance mods without a supporting tune. A turbo kit provides the muscles, but the ECU tune is the brain. Without the brain, the muscles destroy themselves. Bolting on a bigger turbo, larger injectors, or a chip without recalibrating the ECU floods the engine with fuel and air it cannot manage. Aftermarket piggyback tuning boxes are just as dangerous because they fool sensor signals without understanding the full picture and cause unpredictable knock. One LLY Duramax owner towed heavy on an economy tune and cooked the transmission clutches on a steep grade. The tune was never matched to the load. For towing, stick with a stock tune or a dedicated tow tune. A heavy tow tune, adding 25 to 40 horsepower, is the maximum. Performance tunes stay off when a trailer is attached. More fuel means more heat, and more heat with no tune to control. It kills head gaskets, pistons, the transmission, and the turbo. If you modify, pay for a proper tune to match. Number 13 is not letting the engine warm up before you drive it hard, which causes dry start damage. Up to 80% of engine wear occurs during the cold start phase, and here is why. When a turbo diesel sits overnight, oil drains from the top end into the pan, so the first few seconds after a cold start run on almost no lubrication. revving it immediately, or loading it while cold grinds bearings and cylinder walls against metal. Let it idle 30 seconds to a minute to build oil pressure, then drive gently until it reaches operating temperature before asking for full power. And remember, the dashboard gauge shows coolant temperature, not oil temperature. Coolant warms relatively quickly, but oil sits in the pan and takes much longer. Even when the gauge reads normal, the engine may not be truly warm. Do not confuse the two. And keep that cold start habit in mind, because it links directly to an entry higher up this list, the one failure that can send your engine revving past redline with the key already turned off. We will get there. For now, the mistakes are getting more expensive with every number. Number 12 is flushing the engine, or switching a high-mileage motor to synthetic and dislodging sludge into the turbo. Pouring in an engine flush, or a detergent additive, loosens years of built-up deposits. That freed debris travels straight into the turbo bearings and the oil pickup screen. This starves the engine of oil. Switching a high-mileage engine to synthetic does the same thing. Its stronger cleaning action breaks loose the carbon that was quietly sealing worn gaskets. New leaks appear, and the loosened deposits plug the pickup. One 7.3 Power Stroke owner ran nearly 220,000 miles on conventional Rotella T4 with heavy towing and never suffered a single leak. The general threshold is this: under 50,000 miles, synthetic is safe. Above 150,000, it is high risk. If the motor has high miles, either leave it on a quality conventional oil or have it cleaned out deliberately before you switch, never with a casual bottle of flush. Number 11 is replacing parts without finding the root cause. More than 90% of all turbocharger failures are oil-related, either starvation or contamination, and manufacturing defects account for less than 1%. That means the turbo is almost never the disease. It is the symptom. Bolt on a new turbo without finding why the old one died, and the new one dies the same way. A Subaru EE20 owner had a replacement turbo fail again in 2 days because the real culprit, a blocked oil pickup strainer in the sump, was never checked. Before you spend on a part, diagnose the cause. If a head gasket keeps failing, the fix may be ARP head studs, not another gasket. Here is something worth pausing on. Every single entry from 17 down to 11 has been a mistake you make once, maybe twice. The entries coming up are different. These are habits, things you do every week, every fill-up, every oil change. And the damage they cause is invisible until it is not. If this is landing, tap the like button. It takes 1 second, and it genuinely helps. Now, the mistakes start getting expensive. Number 10 is mistaking normal crankcase pressure for a blown seal. Here is something most owners do not know. Turbos do not use rubber seals to contain oil. They use metal piston rings, and those rings are designed to keep dirt out, not to hold oil under pressure. Oil stays inside the bearing housing by gravity and flows downward to the drain port. When the drain is restricted or crankcase pressure pushes back against it, oil accumulates faster than it drains, rises to the rings, and gets slung past them. That looks exactly like a seal failure, but it is a drain failure. Every turbo diesel has some blow-by, gases slipping past the rings into the crankcase, and that is normal. Owners panic, assume a seal has failed, and start replacing turbo seals that were fine. Here is the test. With the engine running, remove the oil filler cap. If the cap bounces or you feel pressure pushing out, you have excessive blow-by. Fixing the turbo will not stop the leak until that blow-by is addressed. Check the breather and measure blow-by before you tear into the turbo. Oil getting into the intake through the crankcase is not just a leak. It is one of the precise conditions that sets up the most violent failure on this list. We will get there at number 4. That is the top end sorted. Now, the fuel system, where one pump can take the entire engine down with it. Number 9 is neglecting the high-pressure fuel pump, especially the CP4. Some modern turbo diesels use the CP4 pump, which is sensitive to low lubricity fuel and running the tank dry. When it fails, it sends metal shavings through the entire fuel system. A simple pump failure instantly turns into a full fuel system replacement. The specific kill mechanism is the fuel filter. A cheap filter with a larger micron rating than the OEM spec passes particles the pump simply cannot survive. The filter fits, it looks identical, and it is quietly letting through the debris that grenades the pump. Keep the tank above a quarter. Use quality fuel with an additive for lubricity. Match the filter micron rating to the manufacturer's spec, and never run it empty. Number 8 is overfilling the oil or using the wrong specification. Too much oil lets the crankshaft whip it into foam, which loses its ability to lubricate. It can also push oil past the seals into the intake. In a turbo diesel, that foamed oil can enter the cylinders through the crankcase ventilation system and act as an uncontrolled fuel source. That is exactly how an overfill triggers a diesel runaway. One 2004 Dodge Ram 5.9 Cummins owner overfilled and drove less than 20 minutes. A massive blue cloud of smoke erupted, and the engine stalled, hydro-locked on its own oil. Just as bad as the wrong spec. A Jeep EcoDiesel needs a low ash oil meeting ACE AC3, and using a cheaper A1B1 oil damages the emissions system. Fill to the correct level, not above, and use exactly the oil grade the manufacturer specifies. We are now in the top 7, and the next 2 entries are where a $5 mistake turns into a $5,000 repair. Number 7 is running a dirty or cheap air filter. The turbo pulls enormous volumes of air. A clogged filter starves it. This forces the turbo to work harder and pull oil past its seals. Oiled filters like K&N style should be avoided entirely because they can allow fine dust to pass through and damage the engine over time. A cheap filter that does not seal lets grit through. That grit sandblasts the compressor wheel and scores the cylinders. Use a quality filter, such as the Mopar part number 53034051AB or the Fleetguard AF 27684 for the applicable engine, and change it on time. A starved filter restricts airflow, but even with a clean filter, you can create the same air starvation with your right foot. Number 6 is lugging the engine at low RPM under load, which spikes exhaust and transmission temperatures. Towing up a grade in too high a gear drops your RPM and strains the engine. This sends exhaust gas and transmission temperatures through the roof. On a Dodge with the 48RE transmission, this cooks the fluid and the turbo together. The numbers matter. According to a former Ford transmission engineer, under 220 degrees Fahrenheit is safe to run all day. Temperatures between 220 and 250 are permissible for 30 minutes at most. Above 250, you must stop and idle in park to keep fluid circulating. Never shut the engine off. Every time you push those temperatures on a hard pull, what you do in the next 3 minutes matters enormously. Number 3 is entirely about that moment. For exhaust gas temperature, under 1250 degrees sustained is safe, and above 1400 you are in the danger zone where aluminium parts start to fail. Downshift, keep the RPM in the meat of the torque band, and watch your gauges when towing. Here is where it all connects. One neglected habit rarely acts alone. A clogged filter starves the turbo. The strained turbo runs hot. The heat cooks the oil. The coked oil starves the bearings, and the failing turbo dumps soot into the DPF. Miss one thing, and you start a chain reaction that takes the whole engine with it. The next few entries are where that chain usually starts. Number 5 is ignoring fuel dilution in the oil. Unburned diesel slips past the rings and thins the oil. This destroys its ability to protect the engine. A 30-weight oil can be effectively thinned to a 20 weight or less by fuel contamination. A Ram EcoDiesel is especially prone to it, and short trips make it worse because the fuel never burns off. Short trips do double damage. That exact same habit is also the single biggest DPF killer on this list, and that is number 1. There is also a safety risk. When unburned fuel accumulates in the exhaust and you apply full load, that fuel and soot mixture can auto-ignite. This creates a fire or explosion inside the exhaust system. The simplest diagnostic is the oil level check. If the level is above the full mark on the dipstick when the engine is stone cold, that indicates fuel dilution. Smell the oil for diesel, and if the level is rising or it reeks of fuel, change it and find the cause. Often bad injectors or too much idling. That thinned oil connects directly to the next entry. Remember the cold start tease from earlier? The failure that sends your engine past redline with the key already off? This is it. Number 4 is ignoring the warning signs of diesel runaway. The engine feeds on its own oil and revs uncontrollably until it destroys itself. It comes from oil entering the intake through failed turbo seals or excessive blow-by. A Subaru Forester EE20 revved to 7,200 RPM and destroyed its bottom end, and the owner had weeks of sluggish performance and poor economy beforehand, which went ignored. Learn the warning signs: blue smoke, a climbing idle, and a whistling or whining turbo. A hiss can be a harmless plumbing leak, but a whine is bearing failure and demands immediate attention. If a runaway starts, and it is safe to approach, block the air intake to stall it, either with a solid dense object or by discharging a CO2 fire extinguisher directly into the intake to displace the oxygen. And after it stops, do not restart the engine until the faulty turbo is replaced, and all intake piping, the intercooler, and the boost pipes are thoroughly cleaned of oil. If any oil remains, the runaway will reoccur the moment you start it. Number 3 is coking the oil by shutting down hot, Run a turbo diesel hard, and the turbine housing glows past 1,000 degrees. The turbo relies on constant oil flow. The instant you turn off the key, the oil pump stops while residual heat pushes turbo temperatures even higher. That heat carbonizes the oil film on the bearings into a hard, abrasive deposit called coking. On the next start, that deposit grinds into the bearing surfaces until the turbo tears itself apart. One 600-horsepower Cummins run with only a 3-minute cool down blew its exhaust wheel apart from the stress. A cool down is completely unnecessary after gentle driving. You only need to let the engine idle after towing, climbing long grades, or hard high boost running. Most of the benefit comes in the first 2 to 3 minutes. So idle 2 to 3 minutes after towing, 5 to 10 after a long steep grade, and at least 60 seconds after any hard pull. Keep that final minute at a low steady idle. Never blip the throttle before shutdown, because that spins the shaft up and starves it of oil instantly. If you have an exhaust gas temperature gauge, idle until it drops below 500 degrees. We have reached the top 2. And what makes these different from everything before is that they are not a single mistake. They are a lifestyle. Number 2 is babying the engine. Modern turbo diesels need to be worked. Once fully warmed up, full throttle pulls and sustained high revs clean the soot from the exhaust, keep the turbo vanes and EGR clean, and burn off the DPF. Drive it gently forever to save fuel, and you clog it, choke the DPF, and build carbon that saps power. As one mechanic put it, these motors are meant to be worked. The trucks he sees with the fewest problems are the ones driven hard. Once a week, warmed up, find a safe stretch and hold it at high RPM for a solid pull. Even break-in follows this rule. The old gentle 1,000-mile myth can glaze the cylinder walls, while varied driving with some hard acceleration seats the rings properly. And that brings us to number 1. Everything on this list has been building to this, because this is the habit that connects babying, idling, fuel dilution, and DPF failure into a single devastating pattern. Number 1 is short trips in city driving that never let the DPF regenerate. This is the most common killer, and 90% of owners are guilty right now. The DPF traps soot. When it fills, the engine burns it off during a regeneration cycle. That process requires sustained speed and load, typically above 60 kilometers an hour for 20 to 30 minutes. Short trips, stop-and-go traffic, and constant idling never create those conditions. So the filter clogs, the engine drops into limp mode, and the bill arrives. Idle hours matter more than odometer miles, so a city truck with 50,000 miles can be more stressed than a highway truck with 150,000. One 2022 Cummins owner drove about 10 miles a day and hit a DPF full warning. Even a 6-hour highway trip failed to clear it, because a single long drive cannot undo months of short trips. Track your regeneration frequency. A properly functioning truck used for constant towing should achieve roughly 1,000 miles between active regenerations, mixed driving about 400 miles. If your truck requires regeneration at intervals of 100 miles or less, something is wrong. And aborted regens are their own damage mechanism. If a regeneration starts when you arrive at your destination, take a short drive to let it finish. Shutting it down mid-cycle stacks up soot and fuel in the oil. The target is simple. One owner in a cold climate found that driving 80 out of every 400 kilometers on the highway, about a 20% ratio, was enough to never trigger a warning. When the warning light comes on, make sure you have at least a quarter tank, because many trucks will not initiate regeneration below that level. Get on a motorway, hold a steady 2,500 RPM for 30 minutes, and watch for the light to clear. The oil matters too. Use a low ash or low SAPS oil, because engine ash cannot burn off and builds up permanently. Also remember that the turbo and DPF fail together. A bad turbo floods the DPF with soot. A blocked DPF backs up exhaust heat and cooks the turbo. When you service one, always inspect the other. 2 facts cut against the panic. 2022 trucks account for over 70% of reported regeneration complaints, which points to a factory defect rather than driver error. Furthermore, a poll found over 80% of turbo diesel owners never faced a DPF problem requiring manual intervention. If your daily drive is a short commute, the smartest move is a cheap petrol car for the commute and the turbo diesel for towing and longer runs. A turbo diesel is a tool built for sustained load and distance. This is the one I told you about at the start, and now you know exactly why. That is all 17. The thread through every one is the same. A turbo diesel is not a petrol engine. It does not want to be babied, idled, run on cheap filters and cheap oil, or used as a city car. It wants to work. Give it the right oil and change it on time. Warm it up, cool it down, and give it the highway miles it was built for. Do that, and it will run 300,000 miles without complaint. Every failure here is preventable, and now you know how. Drop the number of the habit you have been guilty of in the comments, and if you know someone who just bought a turbo diesel, send them this video.